Welcome back to EtherLink AI Insights. I'm Alex, and today we're diving into a topic that's reshaping how enterprises across Europe are building smarter operations. We're talking about AI agents and multi-agent orchestration, and specifically how Rotterdam and other EU businesses are turning this from an exciting experiment into a real competitive advantage.
Thanks, Alex. And honestly, the timing couldn't be better. We're at this inflection point where companies have moved past the chatbot phase, and now they're asking the real question: how do I actually deploy AI agents that work reliably at scale? That's what today's conversation is all about.
Perfect. So let's ground this with a concrete example. Rotterdam's port processes over 13 million container units a year. That's a staggering amount of logistics coordination. How would you explain why multi-agent systems make sense for something that complex?
Great question. A single autonomous agent trying to handle all of that: vessel scheduling, cargo validation, customs clearance, disruption response, would be like asking one person to be a scheduler, a compliance officer, a risk manager, and a crisis responder simultaneously. It doesn't work. Specialization matters. When you break it down into domain-specific agents, each one becomes razor-focused and testable.
So you're saying the real value isn't in having one super intelligent agent, it's in having multiple agents that talk to each other?
Exactly. And the data backs this up. McKinsey's 2025 AI adoption survey found that organizations using multi-agent orchestration report 3.2x higher process efficiency gains compared to single-agent deployments. And here's the kicker: they see measurable results within 90 days. That's not theoretical, that's production impact.
90 days is pretty fast, but I imagine there's complexity in getting these agents to work together without stepping on each other's toes. That's where orchestration comes in, right?
Absolutely. Think of it this way. You have a scheduling agent that optimizes berth allocation, a compliance agent that validates regulations and creates audit trails, and a disruption agent that catches anomalies in real time. But none of that matters if they're not coordinated. That's where the orchestration layer, what we call the control plane, steps in.
I like that term. Control plane. It sounds like it should be a thing, but I'm guessing a lot of enterprises are still flying without one. What happens when you don't have that infrastructure?
That's exactly the gap most organizations face. They deploy agents, but they lack visibility into what those agents are actually doing. They can't audit decisions, they can't trace why an agent made a particular choice, and in regulated industries like finance or healthcare, that's a compliance nightmare. A control plane solves that by giving you real-time monitoring, human-in-the-loop approval for high-stakes decisions, and complete audit logging.
Human-in-the-loop is important, I'm guessing, especially when mistakes could be costly?
Critical. You never want agents making decisions in a vacuum, particularly in logistics or regulated industries. The control plane enforces guardrails, routes decisions based on confidence scores, and makes sure that humans retain ultimate authority. Gartner's 2026 AI Maturity Report actually found that enterprises with formalized control planes achieve 2.8x better ROI on their AI investments and reduce agent-related incidents by 76%.
Those numbers are compelling. So if you're an enterprise in Rotterdam or anywhere else in the EU, what should you be thinking about when you start this journey?
First, forget the idea that you need one agent to rule them all. Design for specialization. Second, build governance into your architecture from day one, not as an afterthought. And third, understand that the control plane isn't overhead. It's your insurance policy and your competitive advantage.
That makes sense. Now, I want to shift gears a bit because there's something really interesting happening on the model side. DeepSeek R1 and Gemini 3 are getting attention for something called reasoning models. What's different about them?
This is exciting because it's a different paradigm entirely. Traditional language models generate tokens sequentially. They're fast, but they don't necessarily show their reasoning. Reasoning models, by contrast, allocate computational resources to chain-of-thought logic. They solve multi-step problems and show their work.
So for an enterprise use case, that means what exactly?
For workflows where accuracy matters more than pure speed, it's transformative. Imagine a compliance agent validating a complex customs declaration. A reasoning model doesn't just say yes or no. It can explain the logic chain it followed, every decision point, every rule it applied. That's auditable. That's defensible.
That's huge for regulated industries. But I'm curious about the technique behind this. There's something called RLVR you mentioned. Can you break that down?
RLVR stands for Reinforcement Learning with Verification Reward. Instead of just rewarding a model for getting the right answer, you reward it for the quality of the reasoning steps it took. That creates adaptive efficiency. A complex problem gets more computational resources. A simple one gets solved faster. It's elegant.
So the model learns not just what to answer, but how to think through a problem efficiently. That's pretty clever. How does that change the way enterprises should think about deploying these models?
It means you can use reasoning models in orchestrated workflows where accuracy and explainability are critical. The compliance agent in that Rotterdam logistics example? That's a perfect use case. The disruption agent detecting anomalies? Also perfect. You get both performance and transparency.
So we've covered multi-agent systems, control planes, and reasoning models. Let's talk about ROI, because that's what ultimately matters to a CFO or a board. How do you measure whether this stuff is actually working?
Good question, and it's not just about speed or cost reduction. You look at process efficiency gains, time from request to completion. You measure consistency. How often do agents make the same decision in the same scenario? You track human overhead. Are we reducing manual intervention? And of course, you quantify error rates and compliance violations prevented.
Those are concrete metrics. But I imagine different industries track different things?
Absolutely. In logistics, you're measuring throughput and turnaround time. In finance, you're measuring risk incidents prevented and audit compliance. In healthcare, you're measuring diagnostic consistency and patient safety. The framework is the same, but the KPIs shift based on what matters to your business.
One more thing I want to touch on, EU AI Act compliance. That's a real consideration for European enterprises, right?
It's absolutely critical. If you're deploying AI agents in high-risk applications, the EU AI Act requires transparency, auditability, and human oversight. A control plane with comprehensive logging and explainable reasoning models checks all those boxes. It's not just good practice, it's legal requirement.
So building governance isn't optional?
Not in the EU, no, which is actually a benefit. It forces you to be intentional about how you architect AI systems from the start. Enterprises that build compliance into their design early move faster and face fewer regulatory headaches down the road.
That's a great note to end on. So if you're an enterprise leader listening to this, what should be your first move?
Audit your current processes. Identify where you have complexity, where you need specialization, and where you currently have blind spots in terms of visibility and control. That's where multi-agent orchestration creates the most value. Start with a pilot, get 90 days of real data, and build from there.
Love it. Simple, actionable, and grounded in data. Sam, thanks for breaking all of this down. For our listeners, if you want to dive deeper into Rotterdam's enterprise blueprint, the strategic implementation framework, and specific control plane architecture patterns, head over to etherlink.ai and check out the full article. We've covered a lot of ground today, but there's plenty more detail there. Thanks for joining us on EtherLink AI Insights.
Thanks, Alex. And to our listeners, if you're thinking about deploying AI agents in your organization, the time is now. The infrastructure exists, the models are ready, and the competitive advantage is real. See you next time.